everybody. Good afternoon. We are getting started this week on expressions and equations. All the work we do with expressions is leading us into solving equations that are more than one-step equations. I'm certain that some of you thought one-step equations were kind of weird because some of it could be solved in your head. Now that we're going to get to two-step and multi-step equations, you will see the process and why it's important. So we're starting off with the idea of expressions. Okay. Now, please know that an expression is a number phrase. I would say a number sentence might have an equal sign and it would have balance. An expression is just a number phrase. So in this expression, please write it down, 2x plus 3 minus y, it has three terms. The term 2x is a product of two factors. It's 2 times x. Okay? So that's a term, that's a term, and that's a term. And this term has two pieces. It's a product of two factors. Okay? Now, we're going to work first on expanding the four-way factor. In this expression, 3 times the quantity b plus 2, we have a product of two terms. Please write that down. This would be 3 times the quantity b plus 2. Those are your two terms. Okay. Now I'm going to use distributive property, which we've studied before. So I'm going to get 3 times b plus 3 times 2. Notice distributing means to hand something out, right? To pass something out. And it got distributed to both pieces inside the parentheses. Okay. So this is me using distributive property. And then I can simplify this. 3b, well, 3 times 2 is 6. And now I have the sum of two terms. Okay. So if you're looking at your homework or something, you're thinking, what do they mean the product of two terms? What do they mean the sum of two terms? Here are some examples. Okay, just so that we're aware of the vocabulary. Well, how would this work with numbers? So here it is again with letters. These are equivalent expressions. That's why they have an equal sign between them. Okay. What if I had an expression that looked like this? 3 times the quantity 2 minus 7. Would that be equal to 3 times 2 minus 3 times 7? Yeah. 3 times the quantity 2 minus 7 could also be equal to 6 minus 21. Now notice, when there's an equal sign, that means you have two expressions that are equally balanced. They have equivalent values. So if I say expression, that's all I should see. I should never see an equal sign. If you see an equal sign, that's now an equation. It's a balanced set of two expressions. Okay. Reminder of associative property, reminder of commutative property. Those are mathematical laws you can use anytime you want to. Okay. So 6 could be 2 times 3, or 6 times 1. 12 could be 12 times 1, 6 times 2, 4 times 3, and also you could reverse these because of commutative property. It could also be 2 times 2 times 3, okay? And this is us looking at the factors. These factors are going to help us in our next section, okay? You already knew factors. You knew what times what makes a composite number, okay? So now what I want to look at, okay, is how do we factor? So again, I have some expressions, okay? And in these expressions, okay, our goal is to remove the greatest common factor of all the terms. Okay, so here I have 8 times a plus 4. Well, I know that 2 times 4 is 8. Oh, does that mean that there's a 4 in each of these terms? There sure is. So I can remove that. I can factor it out. It goes out here, and what we're left with is 2a. And since we took away that 4, 4 times what equals 4? Just a 1. Okay, so that is an example of factoring. Here's another example. 14. 7 times 2 times x plus, we'll look at 21. 7 times 3. And this one, 7 is a common factor, so I can pull it out. I'm not taking it away from the expression. Notice the 4 still stayed with the expression. It just got separated, and later we're going to learn how we can then deal with those separately. So 7, and then I'm left with 2x plus, and there was a 3 here. Okay. Now I want to point something out. This that we just did, going from there to there, that is factoring. Okay. But notice right above, we had the same idea, only we went in the reverse. Okay. Factoring and expanding, you're using the same skills. You're just rearranging an expression in a way that works for you. This is a tool you will use for many, many years. Okay. Now, the last thing I want to share with you, and this is a little bit of a preview into our next lesson, is what do we mean when we say like terms? There's a little bit of assumption sometimes from mathematicians that you know what that means. Okay? It means that they have the same variable to the same power. So 2x and 3x are like terms. They both have x to the first power. Okay? X and x squared are not like terms because this one's to the first power and that one's to the second power. Okay? X and xy. Not like terms. This is just x all by itself. This is x with his friend. Not the same. Okay. 2 and 3 like terms. Sometimes we forget as teachers to tell you guys that just numbers are like terms. The fact they have no variable is what makes them like terms. They're just numbers. Okay, I want to show you one more thing. If I have like terms, 2y and 4y, they can be combined. Because they're like terms. If they're not like terms, you can't combine them. It doesn't work. Okay? So think about this. If I'm at a toy store and somebody says, how many yo-yos do we have? Well, if I have 2 yo-yos plus 4 yo-yos, that equals 6 yo-yos. If they said how many yo-yos we had, and I said, well, we have 2 yo-yos and 4 bouncy balls, they'd look at me like I was crazy. I can't combine the yo-yos and the bouncy balls. So you can only combine like terms. Okay, now this lesson has a lot of detail in it. Please pause. Please replay it. Please kind of go over things again to help yourself and then do the try problems. But just a recap. Terms, okay, some of the definitions, a reminder of distributive property, okay. And when we are using distributive property, a lot of times we're expanding. That's what we're doing. Then when we're factoring, that's the opposite action of expanding, but they are very closely related. And we're going to use them as tools to make equations easier for us. All right, can't wait to see you in class.